So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 352 and in this video we continue with our move assignment operator, and again here in CPP reference.com you go to the language and then from there here to the classes. Here's the move assignment chapter and we scroll down to the example and we will start from here. Down here we have the output of the program, and again I copied all the code here to the compiler explorer. As well I changed here the struct A, the constructor and the move assignment operator a little bit. I wrote here this std out so that we can see when the constructor or the move assignment operator is called. And with that said, let's go to line 56 here, and we see the first thing is that we create two objects A1, A2 with our struct A, and again we have here now constructors, copy constructor, move constructor, here the move copy assignment operator, and here our move assignment operator. So we are just constructing two objects, which means the constructor will be called, and here on the output on the right side we can see constructor called because we have here two objects for A1 and A2. Line 57, there comes our output which just says what we are trying to do. And on line 58 we are trying to assign an object which we create here to A1. Important is here to notice that A1 already exists, which means this assignment here will call an assignment operator instead of the constructor, because that was the difference about the constructor call and the assignment operator call. Okay, let's talk about the right hand side, which is this one here. This is the assignment which we want assigned to A1. We start here with the inner part, which is a temporary object. Again, we have just here the type. We have here no variable name and we have just the parenthesis. This indicates a temporary object. We learned that a temporary object is just an R value, and we are trying to pass now this temporary object as an R value to the function as an argument. So we jump to the function. The function is here defined, and the function parameter here has two options: pass by value or pass by reference. This one is pass by value, but just an R value as a temporary reference, which will bind to the variable A here. So we are creating here a local variable called A, and because this one is a named variable in which we bind our temporary value, this one becomes now an L value. But let's go one step back again. I said here we have created this temporary R value, and we can see this here on the output. When we go here to this line, it says here constructor called because we have created here this temporary object, and now we pass this temporary object here as an argument, and this temporary object will be bound here with an A, and A will call also something because this local variable A must be constructed. In this case again we check the struct A here because we will see how it can react, and when we checked all the constructors we have two options here. We have here the copy constructor or here the move constructor. In this case we know it is a temporary object, and temporary object means it can call here the move constructor to assign it. Okay, the move constructor here will be called. This one we can see here on the side when we go down here to this part, and here we will see that the move constructor will be called. When we go here to the output, it is here the move constructor called, and let's see what the move constructor is doing here. And let's go step by step. We start here in the parameter list. This is just what it is accepting. Our temporary object, this is binding to the named variable O, so it becomes here an L value even if we have here an R value reference. And that is important to know because when we watch now here the assignment, we can see first of all we try to assign S the new value, which comes from OS, which is our object O, and the value S, which is the string from the other object. But you can see here we are using again this move, which may just convert an L value because this is a named variable, so it is an L value, to an R value, which means in other words this assignment S here can perform move semantics. And the question is here, why is this interesting or possible? Because string is not a primitive class, which means it is a custom-made class by a programmer, and custom-made class by programmers can have constructors like this one here, and also can have copy constructor, move constructor, and there we want also try to use the more efficient way. That's why they want also try to use the move constructor or move assignment operator if it's possible. So what happens here is, like I said, the OS here in the parameter list is converted to to this R value, and then it is assigned to S. The string checks his move constructor or copy constructor, and then it assigns the value here to the new S, and the old S becomes valid, but perhaps empty or with a new stats. And all this kind of stuff we can here see on the right side again. First of all, the move constructor is called, and later we will see what happens with the value. After that, we're jumping back to our function here on line 30. We have now assigned this temporary value to our name variable local a, and now it is using this here in the function body, which is just a return a. And interesting is here it is not converting to anything, it is just returning this local variable, which is an L value, just back here. But keep in mind, with functions the compiler can make many optimizations. There are different kind of optimizations. The well known are the return value optimization, named return value optimization, or other kind of optimization, which means all this kind of stuff what I just explained to you here on top could be skipped. Okay, we are returning a, which is an L value, here to this place, but this place here is unnamed. You can see there is no name, but we have the type a, which means we are creating a temporary value here, an R value with this one here. And when we go back to our call, which was this one here, this one becomes a temporary object now, which we try to assign now to AR1 with the assignment operator. And important here is, again, we are trying to assign this temporary object to A1, which already exists. So we are not trying to assign this temporary object and try to create a new object A1, because this is again the difference. That's why the move assignment operator can be called if the requirements are met. So we learned so far that this one is a temporary object and we try to assign it to A1. So we have to check A1's type, which is the struct A on top, and here we have now different options. We know that the constructor here will be not called because we are not creating a new object, so one of these assignment operators will be called, and we have here two assignment operators. The first one we already know, this is the copy assignment operator, and the second one, this is our move assignment operator. And again, we have a temporary object. Temporary object means I can bind to which parameter, this one or this one. We learned so far the temporary object can bind to an R value reference like this one, but it can also bind to this one, which is not normal because this is an L value reference, which means it expects an L value, but we have here an R value and it still can bind to this one. And remember, this was made possible with this word const. Without this word const, you can't bind an R value to a reference. And the reason why they made this possible is sometimes you can't, the compiler can't use here the assignment operator, and so the compiler can at least try to use the copy assignment operator with an R value. Okay, and that's enough for this video, and in the next video we continue from here. And like all time, if you have any questions, write in the comment section. See you next video. Bye and good luck.